Science is like a giant web, where every discovery builds on past and present knowledge. Take Isaac Newton. His idea that the same force makes apples fall and planets move was built on the work of Copernicus, Galileo, and Kepler. Centuries later, Albert Einstein reshaped Newton's theories, changing how we understand gravity. That later helped American astrophysicist Andrea Ghez discover a supermassive black hole at the centre of our galaxy. And between each of these and other milestones are countless other scientists who strengthened this web, paving the way for future discoveries. Let's explore this idea in this video through 4 major scientific breakthroughs. First up, how do we know the ages of Egyptian mummies, when the Maya civilization fell, or when Stonehenge was built? The answer lies in carbon-14 dating, a method developed by physical chemist Willard Libby in the mid-1940s. Carbon-14, an unstable form of carbon, had been discovered by Martin Kamen and Sam Rubin a few years before. Libby built on this by proving it's naturally present in the atmosphere. When carbon combines with oxygen, it forms carbon dioxide, or CO2, which plants absorb through photosynthesis and animals and humans take in through food. All living organisms continually renew their carbon-14 reserves, but when they die, the carbon-14 begins to decline at a steady pace, like a countdown clock. Libby realised that he could determine the time of death by measuring the carbon-14 left in remains up to roughly 50,000 years old. He thought human excrement would have plenty of it, so ran an experiment with gas from sewage samples, and it worked. Then, the scientists tried it on ancient artefacts, and it matched the estimated ages for them, revolutionising archaeology. Libby received the Nobel Prize in Chemistry for his work in 1960, but it didn't end there. Carbon-14 dating has revealed details about ancient ecosystems, improving our understanding of how human activity is affecting the planet. This informed the science in the IPCC reports, helping to raise awareness about climate change. IPCC work, together with former US Vice President Al Gore, was recognised with the Nobel Peace Prize in 2007. Libby's method not only unlocked mysteries of the past, but also provided us a key to understanding the world we live in. A world full of technology, one that would be hard to imagine without the most famous scientist of the 20th century. Did you know we can thank Einstein, in part, for things like smartphone cameras and solar panels? You probably know him best for his theory of relativity, but he actually received a Nobel Prize in Physics in 1921 for explaining one of light's weirdest behaviours, the photoelectric effect. Around 1900, German physicist Max Planck introduced the idea that radiation travels in tiny bundles. Einstein applied this idea to visible light and explained that light acts both as a wave and as tiny packets of energy we now call photons. The photoelectric effect occurs when light, which comes in different frequencies or colours, shines on a material and frees electrons, allowing them to move and create an electric current. But here's the key. Einstein explained that this effect only happens when photons contain enough energy to knock electrons free from a material. This effect helps to explain how solar cells turn sunlight into electricity, why X-ray sensors create images of our bones, or how automatic doors know when to open. Physicists Willard Boyle and George Smith took Einstein's discovery further and transformed the world of photography by inventing CCD sensors, which convert light into digital images. Other image sensors which do a similar job, the CMOS sensors, were improved decades later by NASA for their space missions. Today, you can find them in devices such as smartphone cameras. Einstein's explanation of the photoelectric effect arguably marked the dawn of quantum physics. This theory turned science upside down by revealing that, at the tiniest scales, the universe behaves in ways far stranger and more complex than we ever imagined. Speaking of the tiniest scales, more than 100 years ago, scientists found a way to use crystals to see what things are made of in incredible detail. That's right. They played a key role in one of the biggest scientific breakthroughs of the 20th century, X-ray crystallography. It's so important that multiple Nobel Prizes have been awarded for advances in this field. But what is it? In 1912, German physicist Max von Laue found that when X-rays pass through crystals, they create unique patterns. Soon after, the work of British scientist William Henry Bragg guided his son Lawrence, who formulated Bragg's law, a short equation that, for the first time, decoded these patterns showing where atoms are inside a crystal. That meant scientists could map atomic structures and use that knowledge to create new things, such as making drugs, unlocking the secrets of DNA, or improving electronics. The Braggs received the Nobel Prize in Physics in 1915, and X-ray crystallography has shaped science ever since. Rosalind Franklin used it in her famous Photo 51, which helped reveal the double helix structure of DNA. Dorothy Hodgkin revolutionised medicine by revealing the structures of insulin, vitamin B12, and penicillin, which enabled the production of life-saving drugs and improved medical treatments. She was awarded the Nobel Prize in Chemistry in 1964. X-ray crystallography has even made it to Mars. NASA's Curiosity rover used it to study minerals and search for signs of ancient water on the planet. From deep space to here on Earth, another discovery connects everything together. What do popcorn, Wi-Fi, and the Big Bang have in common? They all involve microwaves. You can think of these waves as extremely energetic radio waves. In a microwave oven, water molecules in food absorb microwaves at a frequency of about 2.4 gigahertz. This makes molecules vibrate and create heat. That's why popcorn pops. Wi-Fi uses the same frequency, but at much lower power levels to carry lots of data and connect our devices without any wires. Long before the internet, in the late 1800s, Indian scientist Jagadish Chandra Bose pioneered microwave technology. One of his devices even made waves like those in 5G today. Yet, Bose's work has been largely forgotten. In the 1930s, Italian engineer Guglielmo Marconi made a telephone that used microwaves, the first of its kind, to link the Vatican to the Pope's summer home. World War II pushed microwave technology forward with the invention of the magnetron. This device enabled advanced radar systems, giving the Allies a big advantage. Soon after, American engineer Percy Spencer noticed a confectionery bar had melted in his pocket as he passed near a magnetron in his lab, leading to the invention of the microwave oven. But microwaves exist beyond our planet. In 1964, Arno Penzias and Robert Wilson found the cosmic microwave background, an echo of the Big Bang that still fills the universe 13.8 billion years later. That discovery earned them a Nobel Prize in Physics. How amazing is it that today, the very waves that connect our devices also connect us to the origin of the universe?